Hey, it's Mom J. We're doing class at a different time today because unfortunately I had other things and couldn't be here, but it's good to see those of you who joined me. Welcome. I'll try not to take too much of your time. I know that dinner time is right around the corner. We're going to go over activities 94 and 95, and then we're going to talk about the test a little bit. Okay. I will post the test on Monday, after class on Monday. Hey, Serena. Hey, Esteban. Hey, Lacey. It's good to see you. I'll post the test on Monday after class, so we have an opportunity to discuss the rest of the questions. I don't want anyone going into the test without having the opportunity to know all the answers to the questions. Okay. So I'm doing okay, thank you, Lacey. How are you? I hope everything is going well. Okay, so activity 94 is what we're looking at. And we're going to jump right into it. All right, so number one, what is the purpose of the card with the star-shaped cutout? Okay. 97 and 98 should have questions. Actually, it does. It's got 10 full questions. I will double check, but I think people started turning it in. But I will double check and let you know. Okay. The purpose of the star card is to function as a control. Okay. It's to see how under normal circumstances you would have absorption of light. So the star card had no film or anything on it, so it functioned as a control. All right, let's take a look really quickly. There is a question sheet. I'm looking at it, Esteban, so you may want to change. You may want to check again. But there is a question sheet for activity 97 and 98, and it looks like there's some people who've already turned it in. So based on what I'm looking at, yes, the questions are definitely there. Okay. Okay, so how do you think the colored film card changes the white light into colored light? Okay. All right, you're welcome. Okay, so the colored card changes white light to colored light. I know that would be a long explanation. If you care to weigh in, that's great. Even though you discussed this earlier, you'd indicate that color is transferred from light through the colored film, although it's hard to provide convincing evidence. The film is acting as a filter, and it's only letting one color through, and it's blocking transmission. So for example, and I happen to have a multicolored shirt on, so I will show you here. This particular one, this shirt is doing, where it's red, it is allowing, it's reflecting red and it's absorbing all the other colors. It's reflecting blue and absorbing all the other colors, so on and so forth. And black is absorbing all the colors. Now those films themselves, what they're doing, because they're a plastic see-through film is that they're actually absorbing all the other colors and letting the color of the film go through. So it's filtering all the other wavelengths but the particular wavelength that you're looking at. Okay. Why do you think only some colors make the strip of the bottom of the phosphorus box glow? Okay. Does anybody have an idea? What do you think makes the bottom of the phosphorus, the strip at the bottom of the phosphorus box glow? And you can give me one word. Okay. Light is a form of what? Energy. You are absolutely correct, Sabrina. Light is a form of energy. So as the light, the more energy that color transmits, the more light that is going to glow back. So if enough energy is absorbed by the material, then the light will be remitted as a glowing light. Okay? Glow-in-the-dark toys are going to have the same effect. So basically, the reason why they glow in the dark is because they absorb light energy. And once you turn the light off, it's remitting that energy as a glow. Is there enough evidence or information that supports or refutes a claim that supports the idea that higher energy colors of white light are damaging to Tia Anna's eyes? Okay, there is evidence that there's a range of energy carried by white light, some with colors blue, violet, that have more energy than others. For example, red or orange. However, there's no evidence that supports that the relatively higher energy in some colors is enough to damage the eyes. So although ultraviolet light, okay, would damage the eyes, you're not necessarily going to experience the visible light spectrum having enough energy to damage the eyes. Sunglass lenses are an example of material that blocks white light and some other high frequency light that is harmful to eyes. Examine the transmission graphs about 3 pairs of sunglasses below. Okay, and those were copied in. Okay, so students would probably identify that you may be more concerned with style or color. So let's go ahead and actually take a look at that picture so that we know what picture we're actually talking about. Okay. So sunglasses are an example of a material that blocks some white light and some other high frequency lights that are harmful to eyes. Examine the transmission graphs of the sunglasses below. Okay, which lens has the best high energy protection for the eyes? So this is what we're looking at here. And this shows 30% of total light transmission. This shows 60% of total light transmission. And this shows 30% of total light transmission. So which lens has the best high energy protection for your eyes? Okay. Now, if you look here, you have your wavelengths where your ultraviolet light and your blue violet light, this is low. This is your ultraviolet and your violets and your blues, and this is low. Here you have a higher level of protection of, well, this one has a higher transmission of ultraviolet light. Okay, but also the violets and the blues are higher as well. So in terms of looking at that question, okay, what your main concern is that you should be concerned about what transmits. So lens 1 provides the best protection. Okay, It goes down close to 0 for the ultraviolet wavelengths. Lens 3 is also nearly as good because it only lets in a little bit more of the UV, and most of the light is transmitted more evenly. Okay, it blocks out more blue and violet light as well. Okay, lens 2 allows the most ultraviolet light to get in, so it is the least effective. Okay, the price for each pair of sunglasses is shown below. Which pair would you buy and why? So lens 1 and lens 3 were the ones that had the better protection. Lens 1 having the higher protection. Lens 1 had a much, much greater price at $80. Lens 3 had the second higher price at $20. And lens 2 had the third highest price at $10. Now also, although lens 2 is the cheapest, it also is the least effective in performing the task that it's meant to perform. Lens 1 is the most expensive, but it also performs the task the best. However, Lacey pointed out lens 3. Lens 3 is almost as good, and if you're looking at the trade-off of cost effectiveness versus benefit, it probably would meet the cost effective to financial benefit ratio. So, you know, it depends. I mean, if someone could afford the $80 glasses, and it's not really going to be a hardship, they'll get the best protection. Okay, but okay, if you're looking at, okay, the book just contradicted itself. Okay, the book contradicted itself. So lens 1 and lens 3 are close to the same. So lens 3, although it does provide better protection, it's literally at 25% of the cost of lens 1. Okay? All right, so we're going to go into 95 really quickly. And I believe 95 was a reading. Oh, no, 95 was a lab. I apologize. 95 was a selective transmission lab that I did where hopefully you got to watch it. There were 3 boxes, and each of the 3 boxes had a film on them, and you were looking at the selective transmission and selective absorption. So which film transmits the most energy, and what is your evidence? Film A transmitted the most energy, and your evidence for that was because the UV level on the card was the highest. Okay, it was the clearest film, which also allowed the most UV energy to come through. What evidence from this investigation supports the idea that sunlight contains invisible waves that behave similarly but not identical to visible light waves? The light waves transmitted through the film carry heat energy to the other side of the film, as indicated by the increase in temperature. In the second part, we switched out the UV cards for thermometers, and you notice that the temperatures did not change evenly, even though they were all positioned in the same area and were hit with the same amount of sunlight. So since they were hit with the same amount of sunlight, it was evident that the cards themselves impacted the amount of thermal energy that was allowed to be transmitted as a result of what kind of rays were allowed to come in. So the light waves that carried the energy to the other side of the film is increased by the temperature. This could be because some visible light in the sunlight heated the box, but also from light that we cannot see. The UV cards were darkened because the film in varying degrees shows that invisible ultraviolet light was present inside the box and was selectively transmitted through the film. So we go back to the ultraviolet light. As the ultraviolet light is transmitted through the plastic into the box, it altered the appearance of the UV card. Films like the ones used in this activity are commonly put on glass windows as energy-saving devices and to prevent sun damage. If the cost of the films A, B, and C from this activity are those listed below, which material would you choose to put on your now there are three choices, A, B, and C. I have to say this, and I'm gonna let you know before I say this that I love you all. But I have to say this. Please pay attention to questions that have choices A, B, and C. This was not a multiple choice question. You had to answer all three. So you were given your car window, your house window, and a window in a home that your windows in your home located in a desert, and your windows in a home located in a snowy mountainous region. So you had to pick which one would work better where. And you could have picked more than one, or you could have chosen A for one, B for one, C for one. So for your car windows, film B would be the best choice because it would keep the interior of the car from warming up too much, but it would also provide ultraviolet protection. Okay, so it's the more expensive film. However, the cost is acceptable because the amount of film that you would need to cover the windows of a car is low. Okay. Film B would be a good choice for the window located in the desert for the same reason. Okay, the temperature in B changed the least. It would keep the interior cooler in the summer, but it would also prevent any benefits from the transmission of wavelengths that would warm the interior in the winter. So, the desert choice would allow you to keep the home cooler, but in the winter, it would not help increase the temperature of the home. Okay. Film C, windows in a home located in a snowy mountain region. Film C would actually work best here. It would block ultraviolet light, but it would allow the transmissions of wavelengths that would warm the interior of the home. So it would block out the harmful rays, but it would warm the house. Okay, what you want to do, I know, Lacey, you mentioned you were confused, and anyone who's watching this, what you want to do is you want to go back to the lab that I did for this, and not enough people watched the lab. So you guys are going to have to watch this before trying to address these questions and make sure you completely understand them. But you want to make sure you watch how the energy transmitted. Okay, there's actual data there that I provided as well. You want to see how the energy transmitted, and you want to see how the ultraviolet light transmitted. And once you look at those, then you're able to make comparisons. Okay? All right, so we've gone over the questions. On Monday morning, I will go over 96, 97, 98, and 99. Okay? And I won't post the test until after that, but remember, you do have a 5-day window. Now, we're cutting things very, very close. You will have a 5-day window for the test. I will open the retake window early. And the reason I'm going to open the retake window early is if you take the test and you don't do well on it, you will have an opportunity to go in and do the retake. So I'll probably open it something like Thursday and give you a week to do it, because your cutoff date for grades to be turned in will be the following Friday. Okay, we'll talk about hard dates on Monday. All right, so looking at the test and what you need to know for the test. Okay, so this diagram here, now the diagram would be in one of the earlier videos that I did change it a little bit, but we did go over amplitude, which is from the origin point to the max point on the wave, either from here to here or here to here. We went over wavelength, we went over the crest and the trough. So you want to make sure you know these definitions. That's very important. Okay? You want to know what a frequency is. In other words, how fast a wave passes, how many waves pass a particular point. In other words, how fast a wave is moving. That's kind of funny. You want to know the difference between the size of the wavelength and the frequency. They have an inverse relationship. The bigger the wavelength, the lower the frequency. In other words, the less waves pass in a particular space. The smaller the wavelength, the greater the frequency. It's going to be moving a lot faster. Okay. The lab that I did on decibels, or the reading that we did on decibels, and I did have the picture posted where it talks about the range of decibels. Okay, you want to make sure you know your decibel ranges. So, for example, if you go from 60 decibels to 70 decibels, you want to know what that range is. Is it an increase of 1 time, 10 times, okay, 2 times, 5 times, 7 times? What is the increase? Okay. Denser medium. You need to know what a dense medium is versus a non-dense medium. Anybody want to weigh in on, give me 2 mediums and identify which one is more dense and why it would be more dense? What would be a denser medium and why? If I were to talk about water and I were to talk about air, which medium is denser? I'm trying to pose the questions in such a way you don't have to type long, elaborate sentences. Water would be denser. That's correct, Esteban. You're right. Water would be denser. If I were to have water and I were to have, let's say, a table, what would be denser? The solid would be denser. So whatever the solid medium is, whether it's a wall or a floor, okay, that would be denser than the water. So you need to understand the density of the mediums, okay, and how you want to know how mediums work. For example, if I have light traveling, it's going to travel fastest through space. It's going to travel the slowest through water. And depending on the solid, for example, a glass or a plastic like this, okay, light is going to transmit through this plastic. So if I were to shine a light through the plastic, you would be able to see it on the other side. But if I were to try to shine a light on my textbook, it would not transmit. So light energy travels faster the less dense the medium is. So in a vacuum, it goes the fastest. It slows down a little bit in air, slows down a little bit in water, slows down a little bit in opaque, translucent or transparent medium. It does not pass through opaque medium. Sound is the opposite. It travels fastest through a solid medium, a little bit slower in water, a little bit slower in air. It does not pass through a vacuum at all. So if you were in space and someone screamed and you were standing in front of them, you would not be able to hear them unless your helmets were touching. And that's because there is no medium to carry the particles that would allow for those sound waves to travel. Okay, so you would need to understand that. Okay. Roy G. Bibb, red, orange, yellow, green, blue, indigo, and violet. You want to know that? Okay, you want to know transmission. You want to understand the definition of transmission, okay, versus absorption. Transmission, what allows light to pass, versus absorption, what absorbs it and does not allow it to pass. Okay, so I'm just looking at basic concepts. Okay, what kind of waves? Okay, we mentioned this in a previous class, the kind of waves that are transmitted to the Earth's surface. Okay, now remember we talked about all of the waves of the electromagnetic spectrum: radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, and gamma rays. Okay, all of those are transmitted from the sun. All of those are electromagnetic waves, but there are some that are transmitted to the Earth and some that are not transmitted to the Earth, or are transmitted to the Earth in very, very small quantities, having to do with the ozone layer, so on and so forth. So make sure you know which ones are transmitted and which ones are not, and why. Okay? Sorry for the dog barking in the background. He sounds angry. Okay. Know the types of ultraviolet, the types of electromagnetic radiation that are harmful to humans. Know which ones are not. Frequency, again, I said to mention to know the difference between frequency and wavelength, understand the difference. Okay. Hello. So that's pretty much what you need to know. I kind of gave you an idea of what you're looking at. Understand the parts of the electromagnetic spectrum. Understand how they, which ones are more dangerous, which ones are less dangerous. Know the parts of the wave. Understand frequency. Understand wavelength. Know all your definitions. Know the difference between a transverse and a longitudinal wave, and which one represents light, which one represents sound. So we've gone over all of those. So I would recommend rewatching the videos that we've done. Okay, if you have any questions, please prepare questions for Monday, because Monday at noon, I am going to be going over all of that. Okay, so that's basically what I wanted to cover today. We'll go over the rest of the questions and I will answer any questions you have. And if I can think of anything else, I will post on Edsby any kind of review material. But if I can think of anything else, I will definitely let you know. And but that's it for now. And I hope you guys have a wonderful day. It is Thursday, which means there is no class tomorrow. So I hope you have an absolutely fabulous weekend. And I will see you on Monday at noon. By the way, I did post all the questions through and including 99, so that you guys would have the opportunity to get those done and to look at those before you take your test. Okay? Have a great weekend. Bye.